For this problem, and those near it, we are asked to give a basis and a solution space in terms of that basis. So the first thing I'm going to do for this problem, number 24 from 4.2, is solve it with its characteristic equation. So introduce r squared minus 10r plus 25 is equal to 0. Now this is pretty easy for us to solve, right? Because you can either use the quadratic formula, or if it's more convenient, you could, say, factor this. Now if I were to factor this, I would have r minus 5 is equal to 0. So what I notice here, sort of off the bat, is that well, there's a weird thing on the screen here. Let's get rid of that. Off the bat is that it's a repeated root. And so when I look at my different cases, I know if I had distinct roots, I could write the solution to this as just two different exponential functions added together with arbitrary constants. And the first one would be sum c1 times e to the 5t. If this were, for instance, 4, it would then just be some other constant e to the 4t. But in this case, they're both the same. So what we need to do is introduce another t multiplying in front. T e to the 5t. Now what's kind of funny is when you're doing these problems, this is really sort of the method you would likely use. You would get here. For this particular number 24, it does ask us for a basis as well. And so the basis, recall we need, since this is a second derivative, we need two possible solutions that are linearly independent. And that's why we introduce this t. So these two functions, e to the 5t and t e to the 5t, both solve my ordinary differential equation, and they are linearly independent. Hence, these form a basis for my solution space. So here's my basis. And the other part of it asks us to write the solution space in terms of these. And so what that is really asking is us to use a little bit more set notation when we write this solution. So the way I could write that, if I want to get my entire solution space for this problem, sometimes you see a fancy S, that's equal to all the y's such that, and then you could write this, c1 e to the 5t plus c2t e to the 5t. You know, even that's pretty good like that. Depends how thorough you want to be. You could also here perhaps include just some of your restrictions that C1, or I might use a little I, CI, so all those different constants are real numbers, and that's probably good right there. I guess I could say if you dislike the CI notation, you don't really have to use it. It would be, for this case, not too much work to also have just written that C1 and C2 are members of R. That little I notation is a lot more helpful when you have 20, 30, however many constants that you don't want to list. Great, so this is really a way of taking the solution that we have and think about it in a vector space context.